Morning everyone. In yesterday, we discussed some more examples, means the 2 or 3 examples about the displacement, the velocity as well as acceleration of a particle executing simple harmonic motion, and also time period. Okay. Now the some more examples on this displacement and velocity as well as the acceleration here. First one, a particle executing simple harmonic motion from extreme position. Extreme position is nothing but what? The equation, the displacement equation for the particle executing or particle starts to oscillate from extreme position is nothing but x is equals to a cos omega t. Okay, position covers a distance equal to, that distance must be equal to what? That distance equal to the half of amplitude a by 2 in 1 second. In 1 second means the time should be what? The time is the total t. It means the small t is 1 second here. We have the equation. It means the particle solution for this one. The particle starts from its extreme position. That's why from extreme position the displacement is, what is the displacement here? The displacement is x is equals to a into cos of omega t. So here omega is equal to 2 pi by t. That is nothing but the time period. We have to calculate this time. X is, what is the x? Here the displacement of the particle, the cover a distance equal to the half of the amplitude is nothing but what? X is equals to a by 2. X equals to a by 2. Substitute here. That x is equals to a by 2. It is nothing but a into cos of omega is nothing but 2 pi divided by t, and t is given in 1 second. T is 1 second right here. Substitute here. Okay, here a gets cancelled. Again it become what? 1 divided by 2 is equal to cos of 2 pi divided by t. Yesterday we solved one problem here about the same like this. Okay, if this cos become here, if you apply the trigonometric, inverse trigonometric function, here it become what? Cos inverse of 1 divided by 2 is equals to 2 pi divided by t. Then cos inverse of 1 by 2 is nothing but what? Pi by 3. It is equals to 2 pi by t. Then pi gets cancelled. Our value of time period is the 6 seconds. Oh, it is a 6 seconds. So simple problems are there. Next one is the amplitude of, one thing is over. By using this one, we have to concentrate what are the given terms here. Okay. Then next one is the amplitude of the simple oscillator, harmonic oscillator, when the velocity of the particle is the half of its maximum velocity. We already know that what is the maximum velocity? That velocity maximum is equals to, it has the maximum displacement. That maximum displacement is nothing but what? Its amplitude. Its maximum velocity is omega into a, or a omega. Omega into a, or a omega is the maximum velocity. But when the velocity of a particle is half of the maximum velocity, now the velocity should be what? Half of its maximum velocity. It is the maximum velocity divided by what? 2. Half of its maximum velocity. Then what is the position of the particle? We have to find the position of the particle is nothing but what? Its displacement. Okay. y is equal to how much? What is the position of the particle here? Then now here we have to calculate. We have one form here, that is velocity and the displacement, both are there. First one, write the velocity equation. That velocity is equals to omega into root of a square minus of what? Y square. We have this formula. Squaring both sides. If you squaring both sides, that equation become what? B square is equal to omega square into root of a square minus of y square. But b is equal to a into omega divided by 2. B is equal to a into omega. Then divided by 2, its whole square is equal to omega square into a square minus of y square. I will write this square directly here. Directly I will write. That become what? A square omega square divided by 4. Then omega square gets cancelled here. Then it become what? A square divided by 4. This equals to a square minus of y square. We have to calculate the value of y. Taking this outside here. Then if you take here, if you take this one to the LHS and take to the RHS, that becomes plus and this becomes minus here. Y square is equal to a square minus of a square divided by 4. Then again what happens? Y square is equal to, LCM is 4 and 4 minus of 3, 1 is equal to 3. That become what? 3a square divided by 4. The next is like this. Then y square is there, we want y, then become what? It is a root of 3, a square root is a divided by root of 4 is 2. This is the answer for this displacement of that. Very simple problems are there by using this one. Okay, these are the displacement and what are the here given terms, so what they want. We have to concentrate first. Okay. Then the next one is the velocity and the displacement. The combination of velocity and displacement. What is the time period and what is the amplitude of that. Okay. Next is example. Third example is its solution. I'll take here. The first given is the velocity of a particle in a section at position y1 and y2. There are two positions. At those positions, the velocities are v1 and v2 respectively. At the position y1, its velocity is v1. At position y2, the velocity is v2 respectively. What is the time period and what is the amplitude of the equation here? We have to find this way here. We have to find the time period as well as the amplitude. First, write the equations. v1 is the velocity, okay? Because the amplitudes are same here. Amplitude and time period, they both are same. First thing, we have to calculate we have to write the two velocities of the particles, okay? The two velocities are here. First one is the velocity of the first particle, call it as a v1. That v1 is equals to what? We already know that one equation, that is omega into, not a maximum velocity, it is the velocity equation only. Omega is constant here and omega into a square minus of y square is there, but y square is a position, the first particle's position is y1. And again that v2 is equal to what happened? Omega into root of a square minus of y2 whole square. Squaring both sides. If you squaring both sides like this, okay? Okay, here squaring both sides, v1 square is equals to omega square into bracket a square minus of y1 square, and here v2 is equals to v2 square is equals to omega square into bracket a square minus of y square is there. First, for the calculation of amplitude, we have to calculate the value of a here, so that equation, there are two equations, call this equation number 1 and call this equation number 2. Subtracting the two equations here. Subtracting two equations. 1 and 2 here. If subtracting these two, v1 square minus of v2 square is equal to what happened? Omega square is into a square minus of y1 square. Then minus of omega square into a square minus of y2 square is there. After that, common term is omega, omega square is common. Okay, omega square is common. The remaining terms are here like this. What happened? We have to find the first time period. Sorry, this is for time period. Okay. Here a square minus of y1 square common is omega square, then minus is here, minus into plus it becomes minus of a square, then becomes plus of y2 square, then a square x square gets cancelled. v1 square minus of v2 square is there. This is equals to what? Omega square into bracket y2 is plus and y1 is minus here. So omega square into bracket y2 square minus of y1 square. Then this, take this one to the LHS, that become what? v1 square minus of v2 square divided by y2 square minus of y1 square is equal to what? Omega square. We know that the value of omega, here the omega is equal to what? 2 pi divided by t. Its square is there. Okay, it is 2 pi divided by t is nothing but what? A root of this one. If you remove this square, root of this one, what happened? v1 square minus of v2 square divided by y2 square minus of y1 square under root. It is equals to omega. Omega is nothing but what? 2 pi by t. That is equals to 2 pi divided by t. Then you want the value of t na? So t becomes the numerator of LHS and this whole term becomes the denominator of the RHS. Then become what? The time period t is equal to 2 pi is same here. It becomes what? Reciprocal of that. That become root of y2 square minus of y1 square divided by v1 square minus of v2 square. This is the time period of the equation here, given equation. Then we have to calculate, then another one is the what? The amplitude. We have to calculate the amplitude here. This is your work. Your work is that your work starts here. Then the two equations are there. Dividing the two equations. Dividing 1 by 2 or 2 by 1 something. If you divide these two, y1 square divided by y2 square, v1 square divided by v2 square, this equals to what? Omega square into bracket a square minus of y1 square divided by omega square into a square minus of y2 square. Omega square minus square gets cancelled. I'll write the final answer here. This its simplification is completely yours. Okay, then become what? Cross multiplication and denominator multiplication become what here? This amplitude is equals to root of a square and y square by 2. That become what? v1 square and y1. Here v1 into it is y2 is there. v1 into, sorry, it is y2, v2. Okay. v1 square y2 square minus of v2 square y1 square divided by, the whole all terms are there, cross multiplication, divided by v1 square minus of v2 square under root. This is the final answer for this one. This is your work. The simplification is your work here. Cross multiplication, common terms, and the common terms get outside and remaining terms become v1 minus v2 becomes here it's denominator of that. Okay, the next problem is here. Example number 4, today's example number 4 here. The particle performing SHM. See, very important thing is the particle performing SHM is found at its equilibrium position. Here equilibrium position is nothing but what? It's a mean position. What is the displacement at mean position? The displacement at mean position is always what? 0. The displacement at the extreme position is the maximum here. But the velocity at mean position is maximum. The velocity at extreme position is minimum. So that here displacement is at equilibrium position is 0. Very important thing is here. The displacement at equilibrium position or mean position is 0. Already told, then I will just write here. Another one is the displacement is 0. It is nothing but the y equal to what happened? 0. If it is y equals to 0 at time t is equals to what? 1. Here y equals 0 at time t is equals to 1. Next, it is found that to have the speed of 0.25 meter per second at 2 seconds. It found that here like this. Okay. If the time period of the oscillation, it is for one oscillation, its time period is nothing but what? 8 seconds. 8 seconds. The amplitude is. What is the amplitude here? First one, we have to calculate the phase. The phase at here, it means the y is equals to a into sine of what is that? Omega t plus of calculating the phi naught. Omega t is a phi naught. But omega is equal to what? 2 pi by t. I will write directly here. Omega is equal to what happened? 2 pi divided by t. But the displacement at t is equal to 1 second, the displacement y equal to 0 because it is at equilibrium position initially. So if it is 0, a into sine of 2 pi divided by t. T is equal to how much? 8. The time t is equal to 8 seconds. Time period is 8 seconds. And this time is 1 second. At 1 second, then plus of phi naught is there. This is the multiplication to the RHS. When you take to the LHS, this 0 divided by a is nothing but a 0. The sine inverse of 0 is again what? 0. Okay, directly I will write here. 0 divided by a is 0. Then using the inverse trigonometric function, sine inverse of 0 is again 0. Okay, 0 is equal to, right here, the sine inverse of 0 is equals to 2 pi divided by 8 plus of phi naught. Sine inverse of 0 is again 0. It is 0. It is nothing but what? 2 by 4. It is 2 divided by 2 1 2. 4 the cancel. Pi by 4 is plus of phi naught is there. If it is phi is not is equals to what? Pi by 4. It take here, it is a positive because it starts from its mean position. Starts from the positive. So that it is magnitude is the phi naught is equals to pi by 4. You can take the positive. If you write here, it is a plus or minus now. If you write here the plus or minus, this become a plus only. Then next thing is we have to calculate at that situation, and it is found to have the speed is 2.5. We have an equation for the velocity. Speed is nothing but here the velocity. Okay. The speed is the v is equal to one equation is there. That is in terms of cos. That is a into omega into cos of omega t plus or minus of phi naught. We already know that the value of phi naught here. Here is something. It is plus or minus. You can take the plus or you can take the minus here, both. V is equal to how much? 0.25, and A is, we don't know the value of A because we want the value of A. A is there, that omega is nothing but 2 pi divided by t, that t is equals to 8 seconds. Cos of, again it is 2 pi divided by t, that is t is equal to again 8 seconds, but the velocity at 2 seconds, we have to calculate 2 seconds, that is 2. It is total time period is here t, plus of, this is how much? Pi by 4, it is pi by 4. 2 ones are 2 4s are cancelled, 2 ones are 2 4s are cancelled, 2 ones are 2 2s are cancelled. 4, it become the numerator of LHS. 4 into 2, 0.25 is 1. It is equals to A into pi into cos of what happened? Cos of pi by 2 plus of pi by 4. Again it is equals to what? 8. And it is equals to 2 and 4, it is again pi by 2, I think, plus is there, na? So, okay, you can take here, it is minus, okay, you can take here minus, don't take this. This becomes what? Minus pi by 4, this is what? Minus pi by 4, minus pi by 4. Then what happened? 2, it is 4 pi and it is 2 pi divided by 8 is there, LCM will become totally its LCM is 4 and it becomes what? Pi by 2 again. A into pi cos of, it is 1 is there. This becomes what? We have to calculate the value of pi here. Cos of pi by 2. What is the value of cos of pi by 2? It is pi by 2 because LCM is 4, here it is 2 and here it is, here it become what? 2, 2 minus 1 is, it is pi by 4. If it is pi by 4, cos of pi by 4 is 1 by root 2. Yes, it is equal to 1 by root 2. A pi into 1 by root 2 is there. If it is 1 by root 2, then the value of A become what? A is equal to root 2 divided by pi. Then you can calculate this one. Amplitude is like this. In terms of like this. Then you can take here minus 1. If you take in plus 9, something is happened, become what? 4 is there, 2 plus 1 is 3 pi by 4. It becomes 3 pi by 4, it will become what? Minus on that. But amplitude is minus, it means what? It is starts from negative direction. It is starts from 3 pi by 4 is that. Okay. This is the amplitude of the particle executing simple harmonic motion which is traveled from its mean position at 1 second. Okay. Then in some more examples we will discuss in next class. Thank you.